This is a lesson on solubility product, or KSP. Some review. Why, when do ionic compounds dissolve? You have to look at the relative attraction between the ions with the ions in the water compared to the ions in the water. If the ions in the water are stronger attraction with each other, then it will dissolve. If it is weaker, then it will not dissolve. And it's on a sliding scale, so the more stronger the attractions, the more things will dissolve. The weaker the attraction between the ions in the water, the less it will dissolve. So there's a spread of values there. Well, we can make a saturated solution. Take a beaker of water and add solid. Keep on adding solid until you get a layer on the bottom, undissolved on the bottom. That would be a saturated solution. Again, this should be a review for you. This is new. If it is saturated on the bottom, if you have saturated, particles aren't just going to sit there. What they're going to do is they're going to be particles are going to dissolve into a solution, and particles are going to precipitate out of solution. This is a dynamic equilibrium. Therefore, if we have an equilibrium, then the rates are equal and opposite when you have a saturated solution. If you have an equilibrium, so the equilibrium in general would look like the solid would dissolve to form the cation, which is positive, and the anion, which is negative. A specific example, calcium hydroxide, solid, will form equilibrium calcium ions and 2 hydroxide ions. So in general and specific case. If you have an equilibrium, you should be able to write a KEQ expression. For the above up here, you got right over left. So the KEQ will equal to the calcium ions times the hydroxide ions squared. Calcium hydroxide is a solid, so that would be over 1. Since they will always have a solid on the left-hand side, the denominator will always be 1. So we have a special case, which is called KSP, for solubility product. Product means there's no division going on. And you just write it positive ion times the negative ion. So this is the KSP expression. If you have that situation, you have the calcium ion concentration is equal to 0.05 molar. Hydroxide ion concentration 0.1 molar. You put those into the equation, multiply it out. 0.05 times 0.1 squared, and you end up with a value of 0.0005. No labels, of course. Things that are very slightly soluble will have a very small decimal answer. This is moderately soluble. There are some that has some to the 10th, and negative 10th, and negative 15th powers. For extra credit, will a solid form? Well, you compare your concentrations to the KSP, at that temperature. The KSPs are highly dependent on the temperature. Think about dissolving sugar in hot water or sugar in cold water, sugar dissolved in cold tea, sugar dissolved in hot tea. The warmer it is, the more it will dissolve. So it's very dependent upon temperature. But in general, fluid solid form, if the KSP is less than the Q, then yes. So you just compare the KSP and the Q values, and if its concentrations are bigger, then yes, it'll be overloaded with ions, and you get a solid. The other way you can get a saturated solution, one way to get a saturated solution is to get a beaker of water, add solid of the compound until it dissolves no more, till you get a sludge on the bottom. Another way would be to get the ions that will react from two different sources, from two different solutions. This happens a lot. You have seen it in the past. Anytime you mix two clear liquids and you get a solid, you are forming a precipitate, which means it's a saturated solution. For example, PBI2, when we did the lab on stoichiometry, the very intense yellow color that we put up on the shelf to weigh overnight or over the weekend, that was an example of a saturated solution before we filtered it off. There is two ways of telling whether you have going to have a saturated solution or not, whether you'll form a precipitate or not. Solubility chart. Solubility chart we used before. It's one that says S or AQ. Depends upon what compounds you have, like nitrates always AQ. Hydroxides never AQ unless it's with ammonia or sodium, potassium, lithium, that type of stuff. This is a general rule. There are exceptions depending upon how concentrated your solutions are. This is a qualitative look at solubility. Will it dissolve, yes or no? The other way is what we just did, KSP. KSP gives a specific numbers for specific temperatures, more detail. And since we're involving numbers, it's a quantitative. Excuse my spelling if it's not right. Quantitative. Okay, so that is the general lesson on solubility using the KSP.